Our main focus for this video is going to be on decimal place values, how to read them appropriately, and how to order them appropriately. But before we do that, I think a review would be helpful with regards to our decimal number system. So our number system has a pattern to it. So notice if we read through the names underneath this number of 7,551,867,423, we see that there's almost a pattern or a cycle here. So after we have ones, tens, hundreds, then we start with a group of thousands. So we start off with thousands, 10,000s, 100,000s. After that, we move into a millions cycle. So we have millions, 10 millions, and 100 millions. Then after that, we start a billion cycle. You can imagine that if I were to extend this number further out to the left, we would have a 10 billions place and then a 100 billions place. So just to note, our number system is called the decimal number system, and we can pick this up when we naturally count. So, for example, moving from 20 to 30, notice that 20 through 29, that's a total of 10 values, and then on the next cycle, we reset to 30, and then begin to do 31, 32, all the way up to 39, and then again, after that 10th value, we reset again to 40, and so on, and so on, and so on. Taking a step back and looking at our number system from a broader sense, say we want to move from one place value to the next largest one. So for example, let's move from the tens place to the 100s place. To do that, we are going to simply multiply by 10. So as we can see here, if we take our tens place, multiply it by 10, this is how we would then move into the 100s place. Take a moment to note, on the left side, look at the multiplication and count how many zeros there are between 10 times 10. Also, take a look on the right side of the equation now and look at the result, or the product. Notice that it also has 2 zeros. Also, let's say we want to make a bigger jump, so maybe we don't want to just move from one place value directly to the next largest. So let's move from 10,000 to 1 million. So in other words, I'm going to go 2 place values away. So starting off with 10,000, if we multiply using a 10 followed by another 10, we will get to the millions place. So again, notice that 10,000 times 10 times 10 on that left side of the equation has 6 zeros. Also, look at the result, or the product, of 1 million. We also have 6 zeros here. Hopefully, it also seems intuitive that if we wanted to move from one place value to a place value that is lower, we would divide using 10. So for example, if we wanted to move from 1,000 to the next smallest place value of 100, we would divide by 10. Notice here we almost have a subtraction of zeros between the two values. So 1,000 has 3 zeros, and then we're dividing that by 10, which has 1 zero. Notice that we have a result of 100, which has 2 zeros in its number. With that part of the review done, now let's take a look at decimal place values. So on the right side of the decimal place, now we have a similar kind of mirroring happening. The only thing here is that we don't have a oneths place, so one with a THS at the end. We start with tenths, followed by hundredths, followed by thousandths, 10,000ths, 100,000ths, and millionths. So again, we should begin to kind of see an almost exact mirroring of what's happening with our place value names on the left side. Again, the main thing that I want to stress here is that we don't start with a oneths place, we start with a tenths place. Now let's move into comparing decimal values. In question 1, we want to compare 2 hundredths to the value of 5 thousandths. In other words, we want to note, is 2 hundredths greater than, less than, or equal to 5 thousandths? In order to accomplish this, what might help out would be to make sure that both values are written so that they have 3 digits after the decimal place. So if we don't see a number, for example, in 2 hundredths, and I want to make it so that there is a thousandths place that's visible, if we don't see that number already, we can assume that it's a 0. So this might make it a little bit easier to compare these two values. So instead of reading that as 2 hundredths, we can read this now as 20 thousandths, because the 0 that we've put in there is in the thousandths place. So we would read that until we get to the last digit. So we have 20 thousandths compared to 5 thousandths. So that tells me that 20 thousandths is greater than just 5 thousandths. Similarly, let's look at question 2. Here we have 14 hundredths, and then we have 1,328 ten thousandths. So again, I'm seeing 4 place values in that 1,328 ten thousandths. So I'm going to make it so that 14 hundredths will actually become 1,400 ten thousandths. So again, looking at these values, I can again see that 1,400 ten thousandths is greater than 1,328 thousandths. Now it is your turn. When you are ready, go ahead and pause the video to work on these problems. I want you to determine which value is bigger using an inequality symbol. So for our first question, we have 207 thousandths, and we are comparing that to 3,947 hundred thousandths. For our second question, we have 9 ten thousandths, and we are comparing that to 1 thousandths. When you are ready, go ahead and press play, and we will review these solutions. So using a similar approach as before, so making sure that both values have the same number of decimal places available, we are able to answer our solution. In question 1, we are going to make it so that both decimal values have 5 digits after the decimal point. So this gives us 20,700 hundred thousandths compared to 3,947 hundred thousandths. So we can see that 20,700 hundred thousandths is greater than 3,947 hundred thousandths. And for question 2, we are now comparing 9 ten thousandths to 10 ten thousandths. And this is why we are going to write the statement that 9 ten thousandths is less than 10 ten thousandths.